Thanks. So, hello, welcome everyone. I'm Michał, Bryś, machine learning engineer at Getting Data, and together with my colleague Marcin Zabłocki, who is MLOps architect at Getting Data, we would like you to join the game today about unlock your data science teams. There are a lot of interesting challenges waiting for us, so we will not wait. Let's get started.
So hi, as Michał already mentioned, I'm Marcin Zabłocki. So let's play a game of unlocking our data science teams. And immediately on our journey, we encounter some data scientists who have some problems to solve, which we as ML engineers and MLOps engineers would like to help them to solve. So what we usually hear from data scientists is that they want to quickly be able to spin up some environment to test their ideas. They want to create reproducible training pipelines. They want to be able to make the experiments reliable. And also they would like to be able to easily switch from the local environments and local data to much larger data sets that are usually stored in the cloud. So when we combine those issues from data science into some hard requirements, you can see those few of them right now. It's usually about time to set up. They want to be able to quickly create those environments for experimentation, and they usually want to have access to machines with more RAM, more GPUs, and more compute power in general. And at Getting Data, the first component of our MLOps platform is the data science workbench. And within this component, we provide our data scientists with isolated environment in which there are a few tools. The first one is usually Jupyter notebooks alongside the VS Code to be able to program and produce code. We immediately ship them with MLflow for our data scientists to be able to track their experiments and trace their ideas from the very beginning. And there's also one additional component, one additional tool that you can see in here that I will come back to shortly. Just remember this logo. And the whole thing is isolated within the Docker container. So we ship Docker containers to our data scientists that they can deploy on their own. And the effect of working in this environment is producing the source code for machine learning projects. But that covers the data science workbench part. So we enable data scientists with Jupyter notebooks in isolated environment, and most importantly, it's fully self-service. So for example, if they decided to switch to different models, they can just shut down either machines or cloud service, switch to different larger machine and run again. But that's not it from the experimentation path. The next path is related to ML pipelines, and why do we need them, and how we can look at this problem. So from the data science perspective, when we look at building ML projects, is that data scientists mostly consider about the experimentation, working with exploratory data analysis, and they use very huge amount of different machine learning frameworks, such as scikit-learn, TensorFlow, PyTorch, and whatever. But there's another perspective of building ML training pipelines, ML projects. Is our perspective as MLOps engineers and ML engineers. It's more from the infrastructure side. We know where the data is. We know how the cloud was provisioned. We also have available a lot of tool sets to run the code in the cloud. So we have execution environment, and there's clearly something missing in the center. And think for a second what that could be. So in here we introduce the concept of MLOps framework, which in our case is Kedro. So when you look at this diagram from the bottom, so as MLOps engineers, this allows us to enable our data scientists with a single abstraction on top of all of the cloud infrastructure, and those cloud infrastructure are coming with different services. So no matter whatever cloud we can provide to our data scientists, the abstraction will be the same. And at the same time, from the data science perspective, so again, looking at this diagram from the top, this is still the same toolset that they've used before, with the common ground being Kedro. And raise your hand if you used Kedro or if you heard about Kedro before. Cool. So a few hands, not that much. So great. So for those of you who know it, this will be a quick reminder, and for the rest of you, it will be something new. So Kedro is a purely Python-based framework that combines software engineering best practices into the data science code, which basically allows us to build maintainable machine learning projects. And the framework itself is right now a little over 4 years old. It was created by a company called Quantum Black, which is an AI company from McKinsey. And last year, Kedro was donated to Linux Software Foundations, so it's fully supported, and it has really active community. You can register, for example, on their Slack, and I believe that on GitHub they have like 8,000 stars right now. So why do we use Kedro? That is the question here. And what features does Kedro bring to the table? So first and foremost, it gives a well-defined structure on top of ML projects. So as it is a framework, and similarly to what you would expect, for example, from Django or from other frameworks like ASP.NET from C# or Spring in Java, frameworks have well-defined structures of the projects. And on the slides you can see right now the example structure of Kedro project. And every Kedro project looks the same. So it has dedicated folders for configuration, it has dedicated folder for notebooks for storing data, and most importantly for the source code, also for documentation. And it is important to have the structure well defined, because if you standardize your projects in your organization using Kedro, every project will look the same. So if you onboard new data scientists or maybe data scientist switches teams, if they both are using Kedro, he will be able to get up to speed really quickly and understand what happens where, because it is standardized. Next thing from Kedro is its extensibility. As I've mentioned, it's a purely Python-based framework. So that means that if you can do something in Python, you can basically do this in Kedro. There is no limitations in terms of what frameworks you can use. You can still use all of your favorite machine learning libraries. You can use data processing libraries like Spark and so on, and Dask. And also you can, for example, deploy it in Docker or in Airflow, or as you will see soon, Michał will show you, you can use many more different execution environments from Kedro. And next thing, a cherry on top here is that since we are building machine learning pipelines in Kedro, it also brings the built-in visualization toolkit, so you can quickly visualize the pipelines and show them, for example, to business owners and explain what is happening there. Or if you are onboarding someone new to the team, you can quickly show them what the pipeline looks like, what is the data flow, what is the data lineage, and so on. And last but not least, my favorite feature of Kedro is the data catalog. So remember, I've talked about the requirement of being able to quickly switch between local and cloud environments, especially when it comes to data loading. So data catalog in Kedro is a feature that allows you to define the data that you want to load or save in the form of configuration file. You can see here I have local catalog with dataset names and some types that are loaded locally from local disk, but I can also prepare a catalog for cloud configuration, and the datasets names are the same, but the types and the sources are different. They can be loaded from the cloud. And the thing that Kedro brings here is that we detach the code of the pipeline that does the data processing or trains the machine learning models from the code that loads or saves the data. So when you look at the Kedro pipeline, you will not see the code, for example, that pandas.read CSV. The framework does all the job for you. You can also extend those data sets with your own implementation. But thanks to that, you can unit test your pipelines and, for example, prepare some test environments and be able to run the whole pipeline in isolated environment, not local, but also, for example, in the cloud one. So that brings us with the pipelines and the dataset switching and maintainable ML code. We assert that with Kedro in our MLOps platform. And that concludes the first building block of our MLOps platform, which is the experimentation with the data science workbench, and Kedro being the MLOps framework of choice. We can build our projects reliably. And that covers the experimentation part, and I'm giving voice back to Michał to talk to you a little bit about the training.
Okay, so as we know everything about the experimentation stage, now it's time to move to the training. Machine learning model training usually starts with the challenge like this. You have to train your model on large data set on the production scale. So how to do this? Usually you will take some cloud environment, because it's most popular nowadays, and make the reproducible, scalable, and maintainable machine learning model pipeline. It sounds easy in theory, but then a lot of questions arise. So first question, how to experiment with the model on the large data when you try to switch from the local sample in, for example, CSV file to some production-grade data sources and large scale of data. Then the next question is about how to manage machine learning model training experiments. So how to track progress of your process and creating your machine learning model, how to manage multiple model on, or even at the end of the day, how will I know that my new model is better than the old one and which one I would like to deploy to the production system. Okay, you've got your model ready. So now how to train that model automatically, because doing everything manually takes time, takes effort, and it's really hard to maintain. And at the end, of course, when you train your model on really large data, at some point you will need some distributed computing, some distributed training options. So also it's really difficult to do on your laptop. You need to do something more. To address that questions and to build MLOps platform for your team, you need a few building blocks. First building block is some process around machine learning model training. So you need to have some options to automate model training, to train your model in the cloud, and even easily switch from some local and small machine to big deployment and do some distributed computing and distributed model training. The second building block for MLOps platform is some process around experimenting on large data. So, for example, your data science teams would like to have easy access to non-local data set, so to easily log into the cloud, take some data from the data warehouse, take some data from some cloud storage, and then train a model on top of this. In addition, also, you need some option to easily join and merge different data sources. This is also a really painful process in the production experiment environment. And here, Kedro again shows up. From the eagle eye perspective, you can see that Kedro lives on the intersection of data science, MLOps, and machine learning engineering. So Kedro also provides some common language and bridges the gap between that groups. And with Kedro, each of that group and each of that team may focus on their area of expertise. So with Kedro, data science teams may focus on machine learning frameworks and training the best-in-class models using TensorFlow, scikit-learn, PyTorch, and so on. The MLOps engineers may focus on providing the right infrastructure for model training with Terraform, Kubernetes, and so on. And machine learning engineers may focus on the machine learning model orchestration and things related to the cloud. So we can see how Kedro simplifies the whole process. Unfortunately, Kedro itself does not care about the exact environment of execution. So Kedro out of the box don't have any support to some specific cloud, but fortunately, Kedro is open source and it's also extensible by plugins. So we at Getting Data developed a series of plugins. They are open source, they are free to use for you, and also we apply this in the commercial projects. So this is kind of guarantee that we maintain it and we create them in the best possible way. So currently we support the Kedro translation from Kedro to Vertex AI, Azure ML, SageMaker, Airflow, Kubeflow, and recently we released support to Snowflake. So with these plugins, you may do the thing. First, you write your Kedro pipelines once in Python in Kedro framework, and then you can translate the pipeline to the format which is ready to deploy on each cloud. It makes the pipeline extremely portable, and of course, from the business perspective, it allows you to avoid vendor lock-in. In practice, how it looks like, this is the same pipeline written once, and you can run it in different clouds. So this is the same pipeline on SageMaker, Azure ML, and Vertex AI. One Python code, one pipeline definition. Plugin means that it's possible to run it on different cloud providers. Of course, this was about Kedro. For ML model training automation, you will need to add some, let's say, old-fashioned classic software development things, like you need to set up code repository, set up some CI/CD, build Docker container, and even think about attaching some hardware accelerators, for example, to your Kubernetes cluster where you train your model. To experiment with large data sets, there is something built in Kedro. So there is something called data catalog, which abstracts the connection between different data sources, between your local environment and cloud. And you can easily even delegate the data preprocessing to the cloud. So you can imagine, like, you define your data source as a BigQuery query. So you query BigQuery to your data. You offload your data preprocessing from the model training execution environment to the data warehouse. You get the preprocessed data set. It is possible out of the box in Kedro. So data catalog is really, really powerful feature of Kedro. On top of this, you need one more thing, which is experiment tracking, because probably over time you would like to know which model performs better, was the neural network or XGBoost or something like this. So to have one source of truth, you need some experiment tracking tool. We, from our experience, strongly recommend the use of MLflow. MLflow is open source tool, so everyone can use it. And it consists two components, let's say. First, it's tracking server. So you may record your model performance metrics, your exported model itself. Even you may record the Python function with the data processing for further use in the tracking server part. And then you may also register your model in the model registry and deploy that model from this place to the production environment. So this is really, really powerful thing to automate your workflow. Just to summarize where we are now on the board. So we talked about experimentation, we talked about training, and now we will cover the next part, serving.
Okay, thanks. Yeah, so as Michał explained, we right now have automated training pipelines that are running in the cloud, and the models are being stored in the in the MLflow registry. So we potentially have hundreds of models that were trained during multiple experiments, but they are still lying there doing basically nothing. So we need something to be able to use them and bring some value to the business. So again, a few challenges rise ahead in the serving part of our MLOps platform. So one of them is related to auditability. So we want to know what was deployed where and at what time. There's also a question of scale. What if we suddenly wanted to scale up scale up serving to more users, because we expect sudden bursts of traffic in our system, for example. And also there are a few things related to reliability after we serve our model. Models can degrade over time, or model can actually behave differently that it was during training once we deploy it. So to translate those challenges into hard requirements, we have a few of them for serving. First of all is about deploying them, connecting them to our applications, and then be able to audit them. So for that, in our MLOps platform, we've built a component called Model Deployer, and it is a GitOps-based toolkit that takes the configuration file, a YAML file stored in Git that our deployment or data scientists or ML engineers can change to point out to specific version that was stored in MLflow, the specific model version that was stored in MLflow. And once they commit it, that means they leave a trace for auditability of the deployments. Our CI/CD triggers the model deployer, and our model deployer is cloud-agnostic, so we usually deploy it to cloud provider of choice, or for example to Kubernetes. Again, we are in the MLflow format, so it's fairly easy to do to adjust this and deploy it as either directly in one of the cloud providers or as a form of Docker container. But that's not it. It's only here we have the deployment part, but after the deployment is successful, we also will trace the state of the deployment in the MLflow models part. So for example, after the deployment passes for production, you will be able to see the state of particular models, where they were deployed and so on. So that covers the model serving part. Again, it's CI/CD. We support batch and online serving, and also we have full traceability and tracking of what was being deployed where. And you might ask, is that it from the model serving? Obviously not. So if you played this game before, there's one little bad thing that can happen, and our model serving can step on it. So that is the data drift. And data drift comes in two flavors. The first flavor is related to training serving skill. So immediately after you deploy your model, suddenly the quality of results is much worse than it was in training. And the second flavor of this bad thing is that you can expect the data drift to appear over after some time. So in order to prevent that, this is the last component of our MLOps platform, which we call model monitoring. So usually, instead of connecting the client applications, the requests one here, directly to our deployed models, we've introduced something called monitoring proxy, which from the client perspective gives the same API as served model, but from our MLOps perspective, it also samples the traffic. And for example, if we deploy it on Kubernetes or in cloud provider of choice, we take a message queue service that is provided there, and we sample the traffic to store it and push it to Evidently AI. So far, we've been using this tool, and we're pretty satisfied with it. And from evidently, you have two options. The first option is the top one, the real-time one that is based on events. In the real-time monitoring, you can see immediately some dashboards with, for example, some real-time metrics that can detect, for example, whether the feature distribution is drifting or, for example, whether the model prediction distribution is off from what you've seen during training. And on top of the Grafana dashboards, you can also build alerting, for example, to trigger or re-trigger the training jobs back in the automated CI/CD training that Michał showed you. And the bottom part is more batch oriented, so you don't have to push everything in a real-time database to Grafana. You can store the predictions in some storage, and for example, then on a weekly basis or monthly basis, depending on your need, you can create the dashboards that will allow you to compare, for example, the data set that you collected from production sampling against your current training data to see, for example, whether there is the data drift, and data scientists can read those dashboards and decide what they would like to do next. So with model monitoring, we will be able to detect both data drift over time and also prevent training serving skew, and potentially we can trigger automated retraining, so our models will not be running wild in production. And that is the last part of our MLOps platform. So from the model registry, deploy them, and we have the model monitoring that can potentially trigger retraining, and it's consumable by production applications. And that was the previous to last path in our game today. Let me give a voice back to Michał to sum this up.
Okay, so now it's time for the most interesting part, just to stitch everything together. So I will talk about MLOps Platform, which is probably, as you know, the game, the most difficult thing to gain, and sometimes it becomes really expensive, like you know how much it may cost. So we built something called MLOps Platform, and what it is. MLOps Platform is our approach and our framework and the reference architecture for the end-to-end machine learning model lifecycle. And yes, this is the place where you can take a picture if you like. I will walk you through that process because this is what we see from our expertise, from our experience in many commercial projects, that this is how the end-to-end process should look like. So this is our proposal. We start with the experimentation, where the data scientists get some data and the data scientist has some space to experiment. We call it data science workbench. Usually it's some kind of Jupyter notebooks. Then when data scientist experimented with the model and knows, okay, I want to try this kind of model, he or she builds the pipeline and push the pipeline source code to the code repository. Just for the version control, just to also allow to plug in the CI/CD on top of that repository. So the CI/CD process take the pipeline code from the code repository and builds the Docker container. Then that Docker container with pipeline code is stored in the container registry, or artifact registry now in GCP. From this place, we may set up continuous training process. So when the new data arrives, or the other signal to retrain the model arrives, we may take the new data, we can take the pipeline with the machine learning model training definition, and we can do model training. The output from that process is trained model, which we store in model registry. You remember MLflow. And then from model registry, we may deploy that model by using the other CI/CD for model deployment. We For offline serving, we may export the model. For online serving, we may expose some service with model serving, and we just plug in this thing to the production application. But this is not the end, because it's really worth to do one more step, just to plug in model monitoring to that model deployment and monitor model performance metrics on production. If the model works, it's good. If you see and you observe that your model degrades over time or something happened on the input data and so on, you may send the event just to trigger the model retraining or alert your data science team. So this is how we see it and how we implement this on our projects. Of course, this is not all-in-one solution. So we propose to build that thing using open source software, and it also allows us to support multiple cloud providers, even the hybrid deployments and some local and private Kubernetes clusters. Of course, you know that this is too simple to be true, because the technology landscape is really, really complex. So you may see each cloud has some dedicated service, plus there are open source services. Okay, I will make a smile. Because I see it's interesting for you. Yes, so this is really, really complex. Also, we've got expertise and experience to do that kind of platforms using that services, and also to integrate, because this is the most difficult part, to integrate that MLOps platform with the production services running currently on the company. So this is also our proposal, how to address that challenges. Yes, we've got some experience. We are happy to share and discuss after the presentation. So thanks for listening, and now I think we have some time for questions.
It depends. So if the data is small enough to fit or to transfer to some bucket in cloud provider, you can put it in the artifact registry. So in MLflow, then it will be accessible for repeatability. For some customers, or for example, for some cases where the data should not be transferred back from the source, we usually trace some metadata about, for example, what dataset was used in terms of Kedro. We can, for example, store the exact shape of the data catalog in MLflow. So when you go back after some time and you will look at the experiment, you will see what was the data source. Okay, so two parts of this question. First one related to Kedro. So yeah, it's growing in popularity. I believe that it will gain more traction as we've built a lot of plugins. And we try to promote them also in the MLOps community, because it's a pretty thin layer to learn, and it brings great benefits. But as with every framework, it has some barrier of entry that you need to jump over in order to make those, in order to be productive. And the second part was related to hard stop. Yeah, thanks. Yeah, that is actually a good question, and we, as MLOps engineers, try to enforce that, because thanks to the hard stop, and once you push the Kedro pipeline code to the source repository, if everything on the right-hand side of the diagram is automated, then you gain and immediately get the reliable training pipelines, because there's always this temptation of, let me change one parameter and just run it. No, it's better to actually put it in a code repository and leave it to CI/CD. That's how you can, build the container, and then once you have all of the dependencies and code in the container, no matter how many times you run it, it will produce the same results. So yeah, this is a hard stop.
I can add one more thing to this also, because from the organization perspective, it's easier to force data science teams to do things this way while it's cheap. I mean, it's easier to do this from the beginning rather than, okay, we will spend months or years on experimenting on some product model, and then we need to add some extra time for model refactoring. I mean, we need to write everything from scratch as a pipeline. So that's... I mean, okay, wrong word, encourage. And also this is what we see from our experience, like, okay, there are like steps of change. Like first there is the resistance, we don't need it. And then after some, okay, we will demonstrate, we will give you some time, we will give you some onboarding training. Data science teams like think, okay, why we are starting this now rather than a few years ago? Because it makes our life easier.